question number 4. We're going to continue. We got a position versus time graph, and we want to describe the motion of the object. So let's go ahead and do it. So what's happening with this object is that it starts, and we need to make this a little bigger. Initially, it starts at negative 40 meters and is not moving. It then goes forward at a steady, fast rate, backwards at a slower rate, and then stops again. So the way I would actually want to have us write this, let's be careful, is we want to write it like this, and then we also want to make note that it goes forward at a steady fast rate until 5 seconds. It goes backwards at a slower rate until 7 seconds, and then stops again. That's really how we want to write this. We want to be careful to make sure that we're really putting this in a lot of good detail. Now, when we draw the velocity graph versus time, let's just kind of be clear. I want to label my axes again from the proper time. So we got 2 seconds, 4 seconds, 6 seconds, 8 seconds. And just for the heck of it, I'm going to label this as 30 meters and negative 30, whoops, down here. So 30 and negative 30 meters per second. And let's go ahead and actually plot this. So it's going to be like 10, it's going to be negative 10. Now when we plot our velocity versus time, first of all, for the first 2 seconds, it's not moving. And for the last second, it's not moving at all either. So now what we need to do is we need to draw this velocity graph. So the first thing is to really do this velocity graph right. Let's get the slope. So this is 2 and negative 40 meters, and then we have 5 and 40 meters. So our slope for this first part here, I'll just draw that. Slope is going to be 40 minus negative 40. That's y2 minus y1 over x2 minus x1, which is 5 minus 2, which is going to be about 80 thirds, and that is about 26.67 meters per second. So I would draw a line about here. Similarly, when we go here, we actually end up going to this final, well, not final, but our position stops changing at 7 seconds, and it's at 7 seconds, it's at 20 meters away from the origin. So what I'll label here is to get the slope. Here we're going to get V is 20 minus 40 over 7 minus 2, which ends up being negative. So if I have this right, that's going to be, see, 40 minus 20, 7 minus 2, so that ends up being negative 20 over, sorry, 7 minus 5 over 2, so I'm going to end up getting negative 10 meters per second. So down here, I have a little 2-second window, sorry, 2, and this goes all the way to 5 seconds here, sorry, and then this goes like that for 2 seconds. So that's how we get our velocity versus time graph. Just to be safe, I'm going to just double check. So yeah, we're good. So this is 26.6, and that's negative 10. And I need to make absolutely sure that I got that right on the PDF file. Now, the distance for the entire trip, let's be careful. The distance, so I go from negative 40 to 40, that's 80 meters. And then I go back another 20. So that means my total distance is 100 meters. My displacement, that's going to end up being x final minus x initial, which is going to be 20 minus negative 40, which is 60 meters. Now when I get the average speed, that's going to be 100 meters, which is the distance divided by the total time of 8 seconds for the trip. And I believe that's 12 point something. Let me just double check. 12.5. And when we get the average velocity, same thing. We're going to get the displacement, though, over the time. So I shouldn't say the same thing. The same idea of taking displacement over time that we've used before. And so when we get that average velocity, we end up getting 7.5 meters per second. So that's problem number 4. In the next video, we'll do problem number 5.